All right, so we're going to start into logarithms. So this is my introduction to it. I want you to consider the following equations. Let's say that I have 10 to some power. Notice the power is the unknown in this case, equals 10. Well, in this case, x has to be 1. 10 to the first power is 10. Easy. Second one, 10 to what power equals 100? Well, you guys should know that. 10 squared is 100, so in this case, x equals 2. But what if I pose the question, 10 to what power is 37? Well, hopefully you realize it has to be bigger than 1, because 10 to the first would give us 10. And it has to be smaller than 2, because if 10 was squared, it would be 100. And the other thing is we know it's probably closer to 1 than it is to 2, but it's going to be some decimal value. We know x must be between 1 and 2, since 37 is between 10 and 100. All right, so now how are we going to figure it out? Well, I could start a trial and error process. I could say, all right, 10 to the 1.5, too low. Remember, I'm trying to get to 37. 10 to the 1.6, too high. So what's between 1.5 and 1.6? Oh, maybe 1.55. That's too low. 1.56, too low. 1.57, oh, it's a little bit too high. 1.565, oh, that's still too low. And you see that I could keep going here, and I keep going more decimal places. If I get all the way out to 10 to the 1.568, I'm really, really close to 37. In fact, if I round, then I get 37. But there must be a better way. And the better way, move myself out of the way here. There is a better way. The more efficient way to solve this problem is with what's called a logarithm. So we have opposites in mathematics. The opposite of the square root is to square something. Opposite of multiplying is dividing. The opposite of an exponential function is what's called a logarithm.